In this video, we are going to learn about t-test. So the difference between t-test and z-test is if my number of observations is less than 30, then I will use t-test. So I've taken a dummy set from the variable which is z-test. So I will take the sample data set and click on data analysis. There are multiple t-sets. So we'll start with paired 2 sample for means, which is most commonly used, and click on OK. Variable 1 range is over here. Variable 2 is my apologies. Variable 1 is over here. Variable 2 is my dummy variable, and hypothesized mean difference. I have to identify what is the difference in mean. So let's say my difference in mean is 10. And my labels is alpha is 0.05. I have labels. My output range is within here only, is here, and I click OK. It says that t-test paired for 2 sample for means variable must have the same number of data points. So now what will I do is I will click cancel, and I will put 1 1 1 1 1 1 1 1 1. It's all dummy, and I will click on data analysis again, and I'll click OK. Now I'll get the output over here. So it says that mean of age is 22, variance is 8, and hypothesized mean difference is 10. There is no correlation. All right. My t stat is 14, and it is greater than my t critical 1 tail and t critical 2 tail. Over here also the same thing applies like we did in z test. If it is greater than t critical, either 1 tail or 2 tail, we reject the null hypothesis. So over here my t stat is greater than t critical. So we reject the null hypothesis in this case. That means there is a difference in the means. However, let's try and understand what if there is very less difference or minimal difference. So let me try and put it something like this: 30, 21, 22, 25, 28, 29, 24, 20, 22, 19, 20. And let's this is male, this is female. So I am trying to compare the ages between male and female, and let's see how does it go. So I will click on data analysis, click over here. I just need to change my output range over here. So we shall delete this, and I will select the different output range, and look at this. My t stat is less than my t critical. That means I can accept this null hypothesis. My correlation is very high. That means difference as in, so the male age and the female age is highly correlated, and the variance is comparable. That's all it means. I can also change this hypothesized mean variance, mean difference. Over here there is not much of a difference in the mean. I can change that mean difference and see how it comes. My mean difference, let's say, is 5, and I click OK. I'll click OK and look at the change in the t stat. Everything else remains the same. Only the statistics will only the t stat will differ. Even this, in this case, it is comparable, and we can accept the null hypothesis saying that there is not much of a difference in the means. So what ANOVA does is it just says that there is a mean difference, yes or no. T stat will also tell what can be the differences, how big is the difference, how big or small is the difference. That's the only difference between ANOVA and Z test or a T test. Z test we can use it for all the sample size above 30, and T test less than 30. That also we can do. For the T test we need two samples over here. In Z test we were okay with one test also. So as in uh, uh, we could have created dummy variable, but here we need two different variable or two different samples or two different data points. All right. So that's pretty much about all these tests. There are more exercises. We urge you to practice more and just interpret the output.